In this lesson, you will learn to graph a linear equation in two variables. Before we begin, we need to know a few terms, and so the first term you need to know is the term coordinate plane. A coordinate plane is simply the entire plane that you see on the right where we will be graphing. And another name for the coordinate plane is the Cartesian plane. And you'll probably hear me more often say Cartesian plane because that's how I grew up, but either is fine, and just make sure you know that both mean the same thing. Another term to know is quadrants. A quadrant are the different sections of the Cartesian plane. You see the prefix quad in the word quadrants. Quad means 4. So notice there are 4 sections on this Cartesian plane, and your quadrants would be right here. So these squares would be your quadrants. And do take note of the numbering. The numbering is important. So we see here, quadrant 1 is in the top right. Many people will confuse and put it on the top left. Quadrant 1 is the top right. And then quadrant 2, 3, and 4 are going to be determined by going in the counterclockwise direction. So make sure you know quadrant and know which one is which. Also, we have what's called the origin. The origin is right here in the center. So we see these two lines going up and down through the Cartesian plane. The origin is where those two lines meet. And those two lines are called axes. So another term to know are those two lines that are called axes. And that's plural for the word axis. So we have an x-axis, which is the one that is horizontal, the one that goes left to right. The y-axis is the one that goes up and down. And if you need a way to remember which one is which, if you tend to forget, a way that I have learned in the past was if you look at the letter Y, if you extend the letter Y, notice how it's going vertical. So the y-axis is the one that goes vertical, and your x-axis is going to be the other one. Some more terms to know. You have the term ordered pair, or another name for that would be coordinates. An example would be something like this. You have in parentheses 3, 1, or it could be 4, -2. It is an ordered pair where you have two numbers next to each other. The first number is going to be your x value, and then your second number is going to be your y value. And another more fancy word that we can give to those is your x values are called an abscissa. So abscissa is the x value of the ordered pair, and then the y value is called the ordinate. If you need a way to remember which one is which, this may be helpful for some of you. But notice x comes first in the alphabet, and then y comes second. Well, the word abscissa starts with an A. A comes first in the alphabet, and then ordinate starts with an O. So O would come second along with the y. So the abscissa pairs with the x, the ordinate pairs with the y. Another term to know is the term domain. Domain are all the values for x. So not just one value, but it's all the values put together. So if it's just one x value, it's the abscissa. And when you put all of them together, that's going to be the domain. And the range are all the values for y. So for example, here we have a set of ordered pairs. So each, if you look at each of these, the 1, here's the 1, the 2, the 4, and the 6. Each individually are called the abscissa. But when you're asked about all of them collectively, we call that the domain. Domain is all the values for x. So in this case, your domain would be the numbers 1, 2, 4, and 6. And then the range are all the values for y. So you have -1, the 3, 5, and 7. So your range would be all 4 of those values. And another mnemonic that might help some of you to remember which one is domain, which one is range. Once again, domain comes first in the alphabet, range comes second in the alphabet. D comes first, R comes second. So the domain are your X values, range are your Y values. So that could help some of you, but as long as you know which one is which, then we're okay. Now as far as graphing these ordered pairs, remember we said that these pairs are made up of an X and a Y component. And we also said, one of the other terms, that this line going across is called your x-axis, and then the line going up and down is called the y-axis. So when you're graphing this, you look at the 3 is going to go on the x-axis because that is your x value. So as we go to the right, just like a number line, numbers get bigger as you go to the right. At the origin, x and y both are 0. So right here, 0, 0, that's not the ordered pair, that's not the graph that we're looking for, but that would be the origin. So then if we go 3 from that, so 3 to the right, so if we go right here, that would take us to that 3 component of the ordered pair. And then it says y is 2. So it's a positive 2. Positive is going to be in the up direction for the y values. So we're going to go up 2 to get this point right here. So that would be your ordered pair 3, 2. The next one would be 0, 4. So 0, 4, your x value is 0, meaning it's not going to go left or right. So then the only thing we have to do is worry about the y component. Y is 4. Positive for the y values is going to be up. So if we go from the origin up 4, we're going to get this point right there. And then if we have negative 3 and negative 1, negative 3 for the x value means we're going to the left 3. So on the x-axis, we go to the left 3, and then we go down 1 because of the negative 1. So our point would be right there. It's to the left 3 and down 1. And then we have 2, negative 3. So x is 2. It's a positive 2. So I'm going to go in the positive direction. So over to the right 2. And then y is negative 3. So y would have to go down 3. So down 1, 2, 3 would take me right there. And then 2, 0. X is 2. So I go to the right 2. And then down 0. Y value is 0. So my ordered pair, my graph for this one would be right there. So here we've graphed ordered pairs. So we just graphed a single point. Now we're going to start dealing with graphing lines. Well, as we begin graphing lines, it's important to know what a line looks like as far as algebraically. So algebraically, a line is anything that can form an equation that looks like ax plus by equals c, where a, b, and c are simply numbers. Then x and y are just there. So for example, these would be lines or linear equations where we have 2x plus 3y equals 4. So notice we have a, or number with the x value, a b, which is the number with the y value, and then a c, which is some other number over here. So that would fall in that category of linear. It doesn't have to look just like that, however. It could have fractions. So here we have negative 4/3 with the x. So that would also be linear. We could rearrange it so that the x may be over here on the right side. But either way, we still have a y, something with the y, equaling a number times the x, and then some other constant over here. It could look like this, where there's no y necessarily, but we have just x equals 1. So we have 0 y's plus an x equals 1. That is also fine. Or it could look like this, where we have 1 times y equals 1 times x plus a 0. So as long as it looks like this, one of these types of equations where we have an x and a y and a number, and it could just be 0 y's or 0 x's, or the constant could be 0 as well. So all of these would be forms of linear equations. They would graph a line when I put them on the Cartesian plane. That is, as opposed to other types of equations, such as x times y, so they're not being added anymore, they're being multiplied. That is not linear. 2x squared plus 3y equals 7. The squared makes it not linear. Here we have 3 divided by y. That would also not be linear. So make sure you can tell by looking at an equation if it's linear or not linear. If it's going to make a line or not a line. Now as we graph lines, let's do a little review back from geometry. To create a line, how many points do you need to make a line? Well, the answer would be 2. We need 2 points to make a line. Well, we know how to graph points. We just learned how to do that. So if we can graph 2 points, then we can just connect the 2 dots and make a line. So doing that, there's 2 different ways to make that happen. So the first way I'm going to show you is going to be in this lesson, where we can use the fact that we can plug in something for x and we can try to find y. Or we can plug something in for y and try to find x. So as we do this, what's going to be an easy number to plug in for x or for y so that we can solve for the other? Well, 0 is going to be probably the easiest number to plug in, because if you plug a 0 in for x, for example, what we're going to get for y can be found pretty quick, because we have 3 times x, but now we have 3 times 0 instead, plus 2y equals 4. Well, 3 times 0 is just going to be 0. That's going to be gone. So what we have is going to be 2y equals 4. Solve this for y. Just divide both sides by 2 to get y equals 2. So one point that we can graph on this Cartesian plane, so that we can graph our line, would be the point 0, 2. When x is 0, y is 2. So we have the ordered pair 0, 2. And we can graph that very quick by going over 0. That's your x value. And then y is 2, so I go up 2 to get that point right there. So we found one point. So we need one more point to find the graph for the line. Well, we plugged a 0 in for x. That was pretty simple. Maybe we could plug a 0 in for y. So let's plug a 0 in for y and see what we get. So plugging a 0 in for y, now we have 3x plus 2 times 0 equals 4. 2 times 0 is 0. So we have 3x equals 4. So x would equal 4/3. So now another ordered pair that we can graph is the point 4/3, 0. When y is 0, x is 4/3. So we could plot that point right there. 4/3 is about 1 1/3. And we connect the dots to get this line right there. So as we graph the line, all we need is 2 points, and then just connect those 2 points with a line. Now as you plug in values, you do not have to plug in a 0 for x or a 0 for y. You can plug in any value for x and any value for y. We just chose 0 because 0 was more simple to work with. But as long as we have 2 points, we can graph the line. I'm now going to graph 2 more like this. Now if you already understand how to do this, you can move on to the later part of the lesson. But if you need the extra practice, the extra help, feel free to watch the next 2 examples that I give you. Here we see 2x minus 3y equals -9. So for this one, we need 2 points. We've said before that plugging a 0 for x and a 0 for y is the quickest way to find those 2 points. So plug a 0 in for x. We can then solve this for y. We're going to have 2 times 0 minus 3y equals -9, which is going to be 0 minus 3y, or just minus 3y. solve for y. We need to get rid of the negative 3, and that's negative 3 times y. So to get rid of that, we can divide both sides by negative 3. That will cancel. So we have y equals negative 9 over negative 3, which is going to be a positive 3. So when x is 0, y is 3, and that can be your first point, 0, 3. So we graph that, and that's going to be right there, over 0, up 3. And then plug a 0 in for y. So then we plug a 0 in for y. We have 2x minus 3 times 0 equals negative 9. 3 times 0 is 0. So we have 2x equals negative 9. We can then divide both sides by 2. And we have x equals negative 9 over 2, which is going to be the same thing as negative 4.5. So my ordered pair would be x is negative 4.5, y is going to be 0. So my graph for that point would be right there, negative 4.5, and then up and down 0. And then the graph of the line would be just connecting those 2 points, and we're done. Let's look at one more example. 2x minus y equals 6. We can plug a 0 for x and a 0 for y to find the other missing part. So if x is 0, we have 2 times 0 minus y equals 6, which is going to leave us with 0 minus y, or just a negative y. And then to solve this for y, we need to get rid of the negative. So this is negative 1 times y, and to get rid of the multiplying, we can divide. So if we divide both sides by negative 1, that's going to cancel and give me a positive y. So on the right side, we have negative 6. And our point would be x is 0, y is negative 6, and we can plot that because it's over 0, down 6. We're going to get that point right there. And then do the same thing for y. Y is 0. We can solve this by plugging a 0 for y. So we have 2x minus 0 equals 6. So then we have 2x equals 6. Divide both sides by 2. X is going to be 3. So x is 3, and y was 0, and that's going to be your ordered pair, 3, 0. So x is 3, so I go to the right, 3, then up and down 0. Connect those 2 points, and we have this graph right there. Now let's move on to a different type of looking equation. This one is maybe not as intuitive, but this would still be a line. This is still a linear equation. So the question is, though, how do we graph this? Because there's nothing to plug in for x. There's no x to plug in for. Well, what we can do is think through the fact that because there is no x, x could really be anything. If I plug, let's say, a 0 for x, well, y would still be 2, right? Does not matter what I put in for x, y is still 2. So my ordered pair here would be 0, 2. Okay, well, maybe x could be something else. X could be 3. Well, if x is 3, y is still going to be 2. So another ordered pair we can have would be 3, 2. And it does not matter what I plug in for x. X can be negative 1, y would still be 2. So if we try plotting these points, 0, 2, you go over 0, up 2, we get this point right there. 3, 2 would be over 3, up 2, be right there. Other point would be negative 1, 2, be right there. If we connect these dots, what we have is going to be a horizontal line. And that would be your graph for y equals 2. Here's another one, y is negative 1. Same concept. X can be anything. X could be negative 3. Y would still be negative 1. So our one point could be negative 3, negative 1. Well, x could be 2. Y could be negative 1. So our point would be 2, negative 1. So what we have is, if we just plot these points, negative 3 and then negative 1, takes me right there. 2, negative 1, be over 2, down 1, takes me right there. Your line is going to be connecting those points, which is going to be a horizontal line. So you don't have to necessarily think through, finding points like that. And you could just know that, hey, if it's y equals something, it's going to be a horizontal line. But it's sometimes helpful to know, to think through it that way in case you get stuck on some of these. Because the next type we have is going to be, skip that over to this one, it's going to be something like this, where you have x equals 3. So it's x equals instead of y equals. But it's still the same thought process, where there's nothing to plug in for y, but y can be anything. So let's say y is 0. Well, x would still be 3. So one ordered pair would be 3, 0. Well, y could maybe be negative 2. Well, it doesn't matter. X will still be 3. So we have 3, negative 2. So for this one, if we plot these points, we have over 3 up 0 would be right there. Then over 3 down 2 would be right here. So the line for this equation would be a vertical line going through those points. Let's try one more. X is negative 2. Same thought process. Y can be anything. Y can be negative 4. X would still be negative 2. So our point would be negative 2, negative 4. Y could be 0. X would still be negative 2. So we have negative 2, 0. Plotting these points, negative 2, negative 4 would be down here. And then negative 2, 0 would be right here. So my graph would be a vertical line going through negative 2. So what we've done in this lesson is we've learned how to graph by finding 2 points. And in a later lesson, we're going to find another way to graph that's sometimes a little quicker. So there's 2 methods. This is method 1, and later we'll discuss method 2.